So today we are going to speak about biomedical instrumentation. Let me share it. So I'm sharing the slide, the courtesy of my colleague from Biomedical Engineering, University Technology Malaysia. So yeah, today's topic is about biomedical instrumentation. So, of course, in general, biomedical instrumentation means that anything that is any devices or any equipment used in healthcare, in the diagnostic or therapeutics. So this can be classified into two different types of devices: the diagnostic device and therapeutic device. So in diagnostic device, the idea or the purpose of the device is merely to acquire information from the patient or from the subject. So not necessarily that subject or that person has to be already been a patient. Yeah? So a patient means that someone who is being treated in a healthcare facility, but could also be anyone healthy, any person. And then we would like to know, to acquire his or her physiological information. So this is the purpose, is to acquire uh, physiological information. Physiological information. Sorry, physiological information. And what we mean with physiological information, of course, information related to the subject's anatomy and condition, the health condition. And here, then further, it is usually meant as biomedical signal. We want to acquire the subject's biomedical signal. What we mean with biomedical signal is any signal comes from the biological system, which which is important from the medical perspective. So here can be from in terms of the in terms of the part of the body uh, that is plays role there. So can be divided into the different anatomical system in the body. So this is biological signal that has medical meaning. Has medical meaning. That's what we call it as biomedical signal. So depending upon the 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 source, yeah, it could be, for example, cardiovascular signal. It could also be maybe, let's say, cardiovascular respiratory signal. Can be also respiratory signal, etc. Yeah, then based on the it can also be classified according to the domain, yeah, physical meaning, to the physical form of the signal itself. So this can be, for example, classified into, let's say, bioacoustical signal, bioacoustic, like stethoscope. Yeah, stethoscope capture the bioacoustical signal of the subject, the sound. In this case, the sound that the organ inside our body produce when they are operating. And for example, the lung, how it produces sound. The heart, when it is beating, it produces sound. When we breathe, also the sound will be created because the air is flowing from through our respiratory tract. Yeah, I forwarded a couple of days ago, yesterday or the day before yesterday, about a research done in United States by MIT team to detect, for example, to diagnose, for example, the uh, the condition, the physiological condition of a person, whether he or she is healthy or having COVID-19 disease, yeah, either asymptomatic, asymptomatic, based on the coughing. Yeah, for example, just now I cough, yeah, based on the coughing sound. So this is included as a bioacoustical signal. Could also be in the form of bioelectrical signal. Yeah, this is quite common now in any clinics. Yeah, so ECG, especially here, ECG in any ICU or EKG, yeah, the heart signal, the heart electrical signal, echocardiography. Then what else? Muscular electromyography, muscular electrical signal, electromyography, EEG, electroencephalography, the brain signal, and many others. AEOG, electrical oculography, the movement of the balls. So bioacoustical, bioelectrical, then also we have biomagnetic. So, for example, like MRI is basically imaging the biomagnetical signal from our body. So capturing the magnetic field that is carried by our it has a transducer now. It has an actuator that give a certain magnetic signal into our body, and it has also a sensor within that MRI to capture the magnetic field after it is interacting with our body. So after it interacts with our body, then the signal changes, and this changes is detected by, by the sensor at MRI. Then it can reconstruct the image to reconstruct our anatomical condition and many others. So based on the physical form, what else? Bio acoustic, bioelectrical, biomagnetic, biomechanical signal. Biomechanical signal, for example, like signal coming from our gait, yeah, from our postural change when we walk, when we stand, when we sit, etc., etc. Bio, what else? Bioacoustic, bioelectrical, biomagnetic, biomechanical, biochemical, also. Biochemical signal. So this is uh, due to the uh, chemical compound within our body, yeah, including our DNA, our protein, and then the composition of the hormone inside within our blood, the blood chemical composition that is related with our physiological condition. This give biochemical signal, so that then goes upward, yeah, from here and here, from which body we measure it, from cardiovascular, respiratory, uh, from neuromuscular system, etc., etc., then give biomedical signal into the system that then can that then some physiological information can be acquired. So based on the ECG, for example, the physician may gather information whether the person is having arrhythmia or whether it is health, whether he is healthy condition, whether he has a tachycardia and different kinds of cardiovascular diseases. So then the physician can obtain a diagnostic. So combining several types of biomedical signal, physiological information from various sensor, then we call that in bahasa we call it menegakkan diagnostic, or in English what does it call? To really establish, yeah, to establish the diagnostic of the condition of the patient. So that is the main goal, yeah, in diagnostic. So the idea of biomedical instrumentation used in diagnostic, especially to develop the tools, equipments, instruments used during the process of establishing diagnostic of a patient or of a human subject. Therapeutics, on the other hand, is not just to acquire, but it is also to the purpose is to influence, yeah, to influence or to affect physiological information, to influence or affect uh, physiological information, to interfere, yeah, physiological information. So it is not only to obtain the information from the body, but then how can we change? How can we change that information towards a better condition, towards the what we call as healthy condition? So we know, for example, that the patient is having arrhythmia, yeah, or what else, dysrhythmia. the rhythm is not correct. So how can we make it correct? So the process of taking the information from the person's body, person's heart, to obtain the ECG signal, the heart beating signal, the electrocardiography signal, is diagnostic. But then how can we make it correct? So this is the purpose of therapeutics. Then, from the perspective of cardiology, we can make it correct by, for example, uh, introducing artificial electrical signal. Because from physiological anatomy, from pathophysiology, we know that a person who is having arrhythmia is because the electrical signal is not does not come from the sinoatrial node. The sinoatrial node is the place in the heart that gives the initial pulse, the rhythm to the heart, so that it can contract and and uh, and then pulse and then pump the blood. So if we depend on the person's own sinoatrial node, maybe the electrical signal is not correctly paced. Then what we can do is to influence the pacing of the electrical signal using artificial equipment, artificial instrument. And then pacemaker was invented. Yeah, previously was something which is placed outside the body, yeah, wearable or something big, cardiac pacemaker, and then it gets smaller, 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 and then implanted into the chest, what we call as cardiac pacemaker. Yeah, cardiac pacemaker. So many of your senior, the alumni of our study program, works in Medtronics, for example. Medtronics is one of the biggest biomedical company in the world, biomedical devices company in the world that produce or manufacture pacemaker, cardiac pacemaker. So in cardiac pacemaker, then it is not anymore just to acquire electrocardiology signal, but instead it tries to affect the person cardiology signal, electrocardiology signal, so that that person will have the correct or the healthy electrocardiology signal. Okay, and it excites the heart. The program, it has a program to excite the heart with certain electrical stimuli, yeah, so that then the heart can beat properly at the correct time. So this is the purpose of therapeutical biomedical instrumentation. Okay, one of the example and one which is quite well known or common is what we call it as cardiac pacemaker. It is also, for example, for uh, 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 the person, the defibrillator. Defibrillator is also a therapeutic equipment that give a very high electrical shock to the heart. So in order that the heart starts to beat again. So because when a person has, for example, cardiac arrest, yeah, then the person then the person heart is being stimulated by this large electrical charge, and the large electrical charge, so that then hopefully it can beat again and then goes to back to its rhythm. So if you often watch movies, you know, for example, ER, emergency room, or even other movies, give me an example. For example, in Doctor Strange, you know, in one of the scene, this Doctor Strange was being the character is being wounded and then goes to this hospital, and then his friend tried to apply large charge to the chest of the wounded Doctor Strange. The heart of the Doctor Strange can resuscitate again. So the equipment is called as defibrillator. Yeah, to defibrillate, so that then the heart can uh, pump again, can pulse again. And sometimes when that person has this for a long period, then the defibrillator has to be made small and even carried around. And we have, for example, implantable ventricular defibrillator (EIVD), yeah, to defibrillate the ventricles of the heart so that it can beat in normal rhythm and being implanted. So this is the uh, purpose of therapeutics. So having said that, then they have different characteristic. Yeah, they have different characteristic. Okay, so between diagnostic devices and therapeutic devices. So similarly here, we draw so here to influence to affect physiological information in terms of classification, also basically similar to diagnostic. Yeah, which biomedical signal also we would like to influence. So it could be then divided based on the anatomical classification, which part. So for example, cardiovascular signal, neuromuscular signal. So or based on the what uh, what form of biomedical signal we would like to influence. So mostly now because our technology is based on electricity. Yeah. Many manipulation form is in the form of electrical energy. So like what many of the equipments that I have just mentioned, defibrillator, cardiac pacemaker, this all give certain kind of electrical energy form to the body to influence the biomedical signal, the physiological information. Yeah, so here can be in electrical, mostly electrical, but can also be mechanical. For example, in the biomechanics session several weeks ago, we had introduction to biomechanics. I give you some example about exoskeleton, orthosis, or also prosthesis that can give the person amplification of the muscle, his or her muscular signal. So maybe that person is already weak, already old, then he could not barely move his limbs, but then what he needs to do is just to have some intention, either give some electrical some neuron signal to the correct motoric neuron, then the sensor of that ortho, orthosis or exoskeleton capture the signal and then amplify that signal to activate a motor, to move a motor, to move the hands or the legs, etc. So this is in the form of mechanical signal. So in terms of anatomical, I mentioned earlier, so example of cardiovascular signal manipulation like defibrillator, among others, defibrillator. What else? The pacemaker, maybe other. Then neuromuscular signal, for example, we have electrical injection, current injection, muscular stimulation. If you know, there are, if you ever if you have ever seen some commercial where some companies sell this kind of muscular exercise, electrical muscular exercise. So the person does not need to move himself, but that device will give some a kind of like electrical shock to the muscle, so that then the muscle can vibrate by itself. Because normally the muscle move, contract, or expand because of the signal sent by the motoric neuron, to the muscle. The signal is sent from our central nervous system, sent towards the peripheral nervous system to the motoric neuron, and then this is sent to the muscle to contract and expand the muscle, contract and relax the muscle. Okay, and so you have then to this circuit of information from your brain to the central nervous system towards the efferent towards the peripheral neuron system, towards the motoric neuron to move certain muscle. But this is a normal way of doing exercise. But this particular company sells this kind of equipment, which, for example, you can place in certain part of your body, muscular part of your body, for example, your stomach, and then it gives some current stimuli to the muscle in that part, in the stomach, for example, so that it can contract and relax, contract and relax. So as if it is doing an exercise. So this is also a type of therapeutic biomedical instrumentation. Okay. So let me save here first. Okay, then. So based on this, uh, the device itself mostly, if this is the person body, yeah, first is the signal from the person body, any signal, yeah. Biomedical signal will be captured by the sensor. Yeah, then there is uh, signal processing involved. Usually, signal processing can be in the form of analog or in the form of uh, what do you call it, digital. We will discuss this more in next week session. From here, then it can be either you transfer that signal into a controller or processor with the advent, in the previously in the old era, maybe that controller or processor is in the form of mechanical machine, but now mostly, and then after that is analog computer, or analog electronics. But now with the advent of computer, since the mid of 20th century, most of the medical instrumentation has some form of digital processor. Yeah. It can be microprocessor, can be microcontroller, can be digital signal processor, etc., etc. So from here, you can either display the data. Yeah, this is display the data in the form of monitor or in the form of chart. Yeah, record it in the paper. You can also record the data if you like. So with electronic memory, it is very easy now, and or stored into the magnetic storage, hard disk, diskette, what else, USB sticks, or being communicated, yeah, being communicated uh, to other device. For example, now with wireless, with IoT, yeah, with IoT, it is quite common to send the information from the local instrument to a server to somewhere else, either in nearby or server in the cloud. Yeah, cloud server. What else? Display, record, communicated. So this is the basic uh, form of diagnostic. Diagnostics only cover this part. Yeah, this is diagnostic. So because the purpose of diagnostic instrumentation is just to acquire physiological information from the subject. But in the case that you would like to do a process, to do control, also to affect that physiological information of that subject. Now, usually it's the other way around. So the signal comes from the controller or processor. So here we have here from the control processor, then some form of signal processing, either to change the information from digital form into analog signal and then amplify it. Signal processing. Then goes into actuator. Yeah, actuator. Actuator convert the electrical signal into the form of signal which we want to interact with the body. So in the case of defibrillator or cardiac pacemaker, that energy form will be in electric energy form. Okay? But in the case of orthosis, exoskeleton, then it will be in the form of mechanical signal, so change with some motors, etc. Yeah. So here, this is when the device is called as the therapeutic device. So the what do you call it? The boundary is a little bit blurred as well. So in the case, what I mean is in the previous era, maybe uh, any therapeutic instrumentation, you do not the device or the instrument do not need to acquire information first from the patient. It immediately converts, like the defibrillator, for example. Yeah. We immediately set, if you look at the movies, we immediately set the energy that we want to put into the person's heart, how many kilojoule or how many joule, then immediately put clear. Then the defibrillator is put into the heart, give shock, electrical shock to the heart, and with the hope that the heart will resuscitate again, is resuscitated, and then can beat again. But uh, in recently, for example, with implantable ventricular defibrillator, first the the system will acquire information from the body with a certain sensor. So this is, let's say, this is the traditional therapeutic where it does not have any sensing function at all inside the instrument, but immediately just give one-way information from a controller or processor to the patient's body with an actuator. Okay, but in a closed loop, we call it closed loop instrumentation. First, the system, the instrument acquire information from the patient's body, and then process, and then try to calculate the correct signal to be given to the person to affect that signal in order that it goes to the healthy condition. Another example that we can give is, for example, insulin pump. Previously, maybe for diabetic mellitus people, when a person is ill with diabetes, and then the physician will prescribe for him or her how many times a day that they need to, for example, inject insulin with certain dosage to his body. But however, now there is research, or even maybe already some company already invented and maybe already produce it, albeit not yet so popular, that an automatic insulin pump where a glucose sensor will measure the level of glucose in the blood, then calculate the correct amount of uh, glucose that it should be, and then afterwards the actuation, it will give a signal to the pump, yeah, insulin pump, to inject the correct insulin level to the blood continuously, or with certain frequency within a day. Not necessarily have to be 3 times a day, for example, in the normal dosage, but can also be whenever it is necessary for that person. And this also happens for any other, for example, chronic diseases, yeah, which require constant control of the patient's level of certain biochemical marker, for example. So this is the trend now. This is the trend that more and more instrumentation becomes smaller and smaller. So, and more function are being integrated. Okay. Okay. So, is there any questions so far regarding this basic classification of instrumentation?
Sir, I want
Yes.
to ask about when after the signal processing for the therapeutic procedure itu kan ada actuatory ya.
Mm.
Itu buat synchronizing the signal with the body ya. Jadi saya rada.
Yes. In the therapeutic devices. Yeah. Yes. Therapeutic information. Yeah. It sends certain signal to correct the certain biomedical signal within the body. So in diagnostic, the purpose is just to acquire information, but in therapeutic device, it calculates with certain algorithm, of course, based on medical science. Yeah, what kind of information need to be corrected and how much it is to be corrected. In the case of implantable IVD, for example, implantable ventricular defibrillator, it gives the correct electrical impulse at the correct time in order that the person's heart remain active, for example. In the case of, then it will be in the electrical form. In the case of diabetes mellitus person, an automatic insulin signal will be given to the person's blood, injected. So it has a micro pump to inject the insulin at the correct level, and how much level and when to be given depends on the biochemical signal that a sensor connected to the device. So it's become one single integrated system, not separated anymore. Previously, or even in still current condition, in nowadays condition, the person, if you know any chronic person, any person who has chronic diabetes mellitus, he has to puncture his finger and then collect the blood glucose information using this portable biosensor. You can purchase it in pharmacies now, yeah, Dr. Watson or Guardian, something like that. And then based on the level, if if the blood glucose level, for example, is too high or too low, then he or she will need to inject certain amount of insulin, or otherwise also take some, I don't know, some other drugs. And this is also with different kind of diseases. Similarly with microdialysis equipment. Microdialysis equipment also most of microdialysis equipment, even until now, it's still one way. So it doesn't have any signal or information acquisition device or sensor. So it just take the blood and then flow the blood into the membrane, and then filter some some particle or whatever from the blood, and then give back the blood to the person. So because the person has kidney failure, for example. But in the future, for example, more and more, I think we'll have more integrated sensor. So acquire some physiological information which is related to the condition of the blood, for example, like the urine level, the uric acid level, not the urine level, uric acid level of inside the blood, which basically a biomarker that give the physical information whether that blood is already good or not. Yeah, because the function of dialysis is basically to replace kidney, right? To replace kidney, and then in this case, it will capture that information and then circulate the blood, clean it until it is good enough to be put back into the patient's body. And there is a trend, although it's not so. Whenever you uh, speak about artificial organ in the future, it will be the kind of like this, a combination of biomaterial and also a smart system. Okay, in the past maybe it's just either of these two, cannot be both. So in the past, like implantable cardiac pacemaker, as well as what do you call it, defibrillator, it only contains something which is of smart system, right? Electronic system. However, it does not have um, what do you call it? It does not have any biomaterials. Usually, it is made from electronic component, electric engineering material, etc. But then that's all. So then you just need to make sure that it is made from biocompatible material. But on the other hand, there are also implant, which is dumb, quote unquote, yeah, or not smart. It is just like implant, orthopedic implant to replace certain part of the certain bones, yeah, because it is broken, etc. Or hip replacement. These are just by material itself, but without any information exchange between the device itself and the body. But in the future, we will see a kind of combination between the two. So the material can also be made from the stem cell or from any organic material, or also inorganic material, but then it has embedded information. So our technology level now is not at that level yet. I'm speaking about anywhere, yeah, around the world, and what we want to obtain in the future is something of a smart artificial organ. So the material itself comes from organic or bioorganic material that is acceptable by the body, but it has certain information exchange so that it can produce the correct amount of of of, of of response to the body. For example, let's say the correct how to counter now immunogenic reaction from the body. If you put an implant into the body, then usually the immunology system will try to resist that implant as well, right? Currently, what the system, what the physicians do, the doctor do, is injecting certain type of drug at certain dosage, at certain frequency of within a day. And this may be correct, and then with uncontrolled, because it is systemic, and then it will flow throughout the whole body. So it may cause some side effect. So in the future, can we just give the drug at the correct amount, at the correct place within the body, especially near the implant site, because that is where the most of the immunogenic reaction happen, right? When the antibody try to resist the implant, instead of giving the whole systemic uh, treatment. So yeah, now when we speak about biomedical instrumentation, the notion or what we think is always, yeah, it is always electronic or it's just always mechanical. No, in the future it will get more biological or also more biochemical, combining all this other stuff, yeah, which you learn from Pak Kholis maybe about biochemical things, but with smartness, with some thinking or processing capability. So I hope that answers your question, Ezra. Okay,
Thank you, sir.
so let's have a break a little while.